Hey everyone, and welcome to Help with Math Homework Series Episode 4. So today, more trigonometry. I don't know what's in the air, but it seems like everyone's struggling with trigonometry. So make sure to stick to the end. We're going to cover double angles and those nasty general solutions. So let's kick off with the first question. Okay, so the first question. Given sine pi on 10 equals square root 5 minus 1 on 4. Find sec pi on 5 in the form a root 5 plus b. And a and b are real numbers. So if you haven't done radians, I'll just make a note. Pi equals 180 degrees. So that means this is 18 degrees, this is 36 degrees. But we don't really need that. You didn't even really need to know what pi is, because you can notice, alright, so I'm told sine pi on 10 equals that. I want to find sec pi on 5. So you got to think, what's the relation between pi on 10 and pi on 5? Well, you can see that this is twice that. So 2 times pi on 10 equals pi on 5. And then we want to find sec pi on 5. So that means we are going to need a double angle formula to do that. Which one do we need? Well, sec, you should realize, is 1 over cos. So we need the cos double angle identity. So we're going to need the cos 2 theta. Now, which cos one do we want? Well, we know what the value of sine is. So that means we want the cos 2 angle theta formula that involves sine. There's 3 of them, but only one that has sine by itself, which is that one. So if I use this formula, sub theta as pi on 10, that means cos pi on 5 equals 1 minus 2 sine squared pi on 5. So now, all I need to do is sub in sine pi on, whoops, sorry, that's 10. I need to sub in sine pi on 10. So let's do that. Now I need to square that. So I can do that straight away. So to square this, we square top and bottom individually. So to square the top, that's going to be a perfect square. We square the first term, 5. Double their product, minus 2 root 5. Plus the last term squared, 1. Over, what's 4 squared? 16. Let's simplify that. Now in one go, 6, 2, 8, alright. 3 minus root 5 on 4. What do I do here? I cancel this 2 with the 16, that takes it down to 8. I added the 1, that's 6. And then there's a factor of 2 that cancels at the bottom. So now let's just put all that as one fraction. So then that's 4 minus 3 plus root 5 over 4. So notice when we combine it into one fraction, we're adding a whole number with a fraction. So I did make a tutorial on that the other week, adding whole numbers with fractions instantly. You just times the denominator with the number and add it to the top. And this minus affects both of these. So that's why this is a plus here. So that's just 1 plus root 5 on 4. So then sec pi on 5 is the reciprocal, which means we flip it. Actually, I want to write with root 5 first. Now if we look at the answer, it says put in the form a root 5 plus b. We have a root on the bottom, so we're going to need to rationalize the denominator by timesing top and bottom by the opposite sign. So on top, that's 4 root 5 minus 4. On the bottom, that's difference of 2 squares, 5 minus 1, which is 4. And what you'll notice is this 4 will cancel if each of these falls on top, so we're left with root 5 minus 1. It's a very simple, nice looking answer now. Okay, so whoever's question this was, I hope this helps and you see how to do this nice and easy. All right, let's get to the next one. Okay, so the next question. All right, so we've got general solution here. So I've written down the example I'm going to do. Right, there's a lot there, so I'm just going to show you two different ways as a bonus of how to solve this using general solution. And then it says to find the values of theta in the domain negative pi to pi. So the first way we deal with trig equations is we try to solve them by reducing it by factorizing. So we want to sub in the double angle identity here, 2 sine theta cos theta, bring the cos theta over. That way we can factorize it out and solve it that way. So if I take cos theta out, that's 2 sine theta minus 1 equals 0. Then this turns into cos theta equals 0, sine theta equals a half. So now I have to find the general solution for each of these. So the general solution formula for cos theta equals A is theta equals 2n pi plus minus cos inverse A, where 2 pi, remember, is 360 degrees. So then cos inverse 0 is just pi on 2, right? Because cos pi on 2 is 0. Now sine. So if sine theta equals A, the general solution is n pi plus negative 1 n sine inverse A. Now there are two different formulas if we split n into even and odd cases, but why learn two formulas when you can just learn one? So this is a better formula to learn. It covers all cases. So then sine inverse a half is pi on 6, right? 30 degrees. So now to solve in the domain negative pi between pi, we just have to sub different values for n in. So let's start with the most basic one, 0. So if we put 0, we're going to get plus or minus pi on 2 here, which is inside. So that's good. If we put it here, we're just going to get pi on 6. That's in there as well. Let's try the next one, 1. Now if we put in 1, 2 pi plus pi on 2 is too big. 2 pi minus pi on 2, still too big. That's 3 pi on 2, that's still outside. Let's put it in here. So it'll be pi minus pi on 6, 5 pi on 6, that is inside. So you can see now if I go to n equals 2, it'll be way too big. So we go down, and so let's check negative 1 then, right? Because we can sub negative values in because we've got a negative domain. If I put negative 1, negative 2 pi plus 2 pi, still outside, right? That's negative 3 pi on 2, which is still out here. Negative 2 pi minus pi on 2, way too negative. Okay, let's check here. Negative pi minus pi on 6. What's outside? So there is no solutions here. So then these are the final four values of theta, and that's how we solve using general solution. So now let's look at the bonus method of another way to solve this. So when we're solving general solution, or trig equations in general, we only want one trig value. So what I could have done here, instead of using a double angle identity, is I could have converted this to cos pi on 2 minus 2 theta equals cos theta. See, I use the complementary identity, right? The 90 minus theta. And the reason I changed sine to cos is because that general solution looks a little nicer than the sine one, so negative 1 to the power of n. So now if I apply the general solution formula, this is pi on 2 minus 2 theta equals 2n pi plus or minus theta, because cos inverse of cos theta will just give you back theta. And I picked to put this one first because it would look better to have this here than that with a plus or minus. So what happens now is this is actually two different equations with the plus and the minus. So I have to split it into two equations, plus theta and then minus theta. And then I have to rearrange and make theta the subject. So here I would bring it over here. So I get 3 theta equals pi on 2 minus 2 and pi, just by swapping these. And then in one go I can write theta equals pi minus 4n pi over 6. Let's do the same over here. I take it over here. If we swap it, we get theta equals pi on 2 minus 2n pi. Or if I want, I can write it as pi minus 4n pi over 2. So again, that's just different ways to write theta, and then to get the values, you just sub in n again. Alright, so I hope this makes dealing with general solution a little easier. The key is just to remember the general solution formulas. Like if you know those formulas, then it's not too hard to apply it. And then to solve it in specific domains, you just sub different n values in. Alright guys, that's it for episode 4. So make sure to join the free Maths Help group. Link will be in the description so that you can get your questions featured here. I'll see you guys next week.